Okay, so in this video, we're going to continue trying to write down the net ionic equation for this acid-base reaction that we balanced. So we're just continuing on with where we left off. So I've recopied this equation that we finished balancing last time. And we figured out what all the phase labels were and that this was going to be insoluble. So it's going to precipitate out of our reaction. So this is a precipitation reaction as well as an acid-base neutralization reaction. Pretty cool, huh? Yeah, I thought you'd be impressed. Alright, so now we want to write the net ionic equation. Steps in writing the net ionic equation. First thing that we need to do is write the overall ionic equation, and that's going to help us figure out what our spectator ions are. So we want to write the overall ionic equation. And the way that we're going to do that is we're going to ionize or dissociate. So I'm just going to write dis here. We're going to dissociate all strong electrolytes. Okay, so they must be strong or we're not going to dissociate them. So anything that is a weak electrolyte or is a non-electrolyte, we're not going to dissociate those. So let's just remind us, what are things that are strong electrolytes? Well, because we're going to need to know that. Things that are strong electrolytes are all soluble ionic compounds. All soluble ionic compounds are strong electrolytes. Also strong acids. Alright, so strong acids. So if you're not on this list, then you're not going to be a strong electrolyte. And when we write the overall ionic equation, we are not going to dissociate those. Alright, so we're going to write the overall ionic equation first. Then after we've done that, I'm just going to go ahead and list these steps. Then we're going to remove spectator ions. So how do you identify a spectator ion? Well, it'll be the same on both the reactant side and the product side. So spectator ions you can identify because they're unchanged in the reactant side and the product side. So if you see something showing up that's the same thing on the reactant side and the product side, you can get rid of those. We can cancel them from both sides of the equation. All right, so we're going to remove the spectator ions, and then we will have our net ionic equation. Alright, so let's go through and do these two steps then for our equation up here. Overall ionic equation. So we're going to dissociate all strong electrolytes. So anything that has an AQ beside it that is also a strong electrolyte, we are going to dissociate. So this guy right here, AQ beside it, and it's a possibility. Let's see, what is this? Oh, this is phosphoric acid. Oh, but it is not a strong acid because it is not on our list of strong 7 acids. So what are we going to do with this guy? We're going to not dissociate it because in solution it pretty much doesn't. So it's going to stay connected. So we're going to just copy the formula back down. 2H3PO4 aqueous. All right, so we do not dissociate that. Plus, now we've got barium hydroxide. It's aqueous, so I know it's possibly a soluble ionic compound. Alright, so since it has AQ beside it, not solid, I can go ahead and assume it is aqueous. But remember from our solubility rules that we just talked about that all hydroxides are insoluble except those of calcium, barium, and strontium. So this is one of those exceptions, right? So this guy's a soluble ionic compound. It's a strong electrolyte, so I'm going to dissociate it. So it's going to break up into its separate parts. So what are the separate parts, right? The separate parts are barium, so we're going to separate the barium out, and then we're going to separate out the hydroxide. So those are the ions that are going to break apart there. So let's do that. We're going to have 3 of these guys. So we've got 3 barium 2+, and we're going to write AQ beside them, right? Then we've got 2 times 3. See how I got that? I got 3 of these barium hydroxides, but I've got 2 hydroxides per barium hydroxide. So 2 times 3 is 6. So I'm going to have 6 OH- ions. AQ right there, dissolved in water. All right, so here's our reaction arrow now. And what are we going to have for the products now? We need to think about over here. So barium phosphate. All right, dissociate all strong electrolytes. Not a strong electrolyte. Why? Because it's not soluble. I said soluble ionic compounds are strong electrolytes, but this is insoluble, so we're going to leave it together and just write it as Ba3PO4 2 solid. So that's our precipitate. And over here, water is a non-electrolyte, right? So it doesn't fit this category, so we're not going to break that up either. So we're just going to write it as 6 H2O liquid. All right, and then we're going to remove any spectator ions. So we want to look for any ions that are on this side that are also on this side. And there are none. So this reaction does not involve any spectator ions at all. Okay, so what's going on is these OH minus ions are pulling off these H pluses. So that's one part of this reaction to make water. And then the other thing that's happening is these barium cations are hooking up with these phosphates to make an ionic bond and precipitate out as this solid. So I'm going to write PPT for precipitate underneath it because that has precipitated out of our reaction.